headline is not just that this is a fast Mac. It is that one desktop can expose 512 gigabytes of unified memory to the GPU. That changes the class of open weight model you can load locally, from ordinary 70 billion parameter models all the way to models in the 600 billion plus range. There's one constraint on every number that follows. The M5 Ultra was announced today and has not shipped, so independent token per second tests are not available yet. Apple gives us the hardware: 512 gigabytes of unified memory, 1.2 terabytes per second of bandwidth, and up to 80 GPU cores with neural accelerators. First, the thing that makes this machine unusual: model fit. Model fit ladder is the reason to buy the 512 gigabyte configuration. OpenAI's GPT-oss S120B checkpoint is only about 61 gigabytes. Qwen 3235B at 4-bit used about 124 gigabytes. Llama 405B used about 217. DeepSeek R1 at 16,000 token context reached about 410 gigabytes and still fit. Raw parameter count is not the same as work per generated token. Llama 405B is dense, so essentially the whole model participates each token. DeepSeek R1 is mixture of experts and activates only a fraction. On the same M3 Ultra baseline, Llama generated about 2.9 tokens per second, while DeepSeek reached 19.3. This is the clearest proof point. DeepSeek R1 at 4-bit used about 392 gigabytes at 1,000 token context and generated 19.3 tokens per second. At 16,000 tokens, memory rose to about 410 gigabytes and generation fell to 14.7. That is still a practical single-machine result before M5 Ultra exists in reviewers' hands. Fit is only half the story. Now, what actually feels interactive? Here is the speed hierarchy on the older M3 Ultra, which is useful because all three are measured on the same class of machine. Qwen 3235B at 4-bit reached about 28 tokens per second. DeepSeek R1 reached 19. Dense Llama 405B managed only about 3. Architecture matters at least as much as headline model size. Model weights are only the starting point. As context grows, attention and cache costs rise. Qwen 3 falls from about 28 tokens per second at 1,000 tokens to 10 at 64,000. DeepSeek R1 falls from 19.3 to 14.7 by 16,000. So a model that technically fits can still become much less interactive at very long context. If you want a large model that leaves the Mac breathing room, GPT-oss S120B is a very comfortable fit. It has about 117 billion total parameters, but only about 5.1 billion are active per token, and the official checkpoint is about 60.8 gigabytes. On a 512 gigabyte machine, that leaves enormous room for long context and other workloads. So which models are actually worth running on this machine? A practical shortlist looks like this. GPT-oss S120B when you want lots of memory headroom. Qwen 3235B is the most attractive measured speed versus size point here. DeepSeek R1 is the giant reasoning flex that is still interactive. Llama 405B absolutely fits, but at around 3 tokens per second on M3 Ultra, I would run it only when I specifically wanted that dense model. For software, I would not overcomplicate the first setup. Use LLM Studio to browse and test models. Move to MLX or OMLX when you care about Apple-specific performance and benchmarking. Llama.cpp gives broad GGUF compatibility and tuning. Llama is useful when the goal is to turn the Mac Studio into a simple local model server for other apps. Limitation is worth keeping. Memory capacity does not turn every enormous model into a fast one. Dense models can still crawl, and long context still costs you. But the important change is real. A maxed Mac Studio can host 600 billion plus open weight models on one quiet desktop. That is the useful answer to how big an LLM this machine can run.